All right. All right, let's get after it. Okay, so today I'm just going to be analyzing some graphs. I might go in and look at do a little bit of work on the project for yeah. But yeah, I think today I'm just going to do some just a bunch of graph analysis. So actually, let's update the stream information. Let's come here, let's do this.
You are the...
Okay. All right. Let's get after it. Okay, so copy, paste, wait. I'll put that there. That's what I'm working with today. Let's see. Just do that. This is the article that I'm looking at. But yeah, so yesterday, the day before, I can't remember when, but we looked at this Florida section of the path of Hurricane Helene. Honestly, like, just looking through these images, this is just Florida. It looks pretty horrible. I mean, that house right there. Yeah. This house is floating away. That's a fun day. Jeez. Yeah, this is a horrible storm. But yeah, so now we're gonna look at that a little bigger. Now today we're gonna look at both the path through Georgia and the path through, yeah, that's pretty horrible. Did I pass it? I think I did. Yeah, I did pass it. So today we'll look at the path through Georgia and then the path through North Carolina and Tennessee. So let's look at the path through Georgia first. All right, pop that open in Paint. Okay, let's talk about what I like, what I don't like, and give it a grade. So, Georgia, South Carolina, battered by Helene. I think this is it's a good title. For me personally, where I'd like maybe a bit more detail, but it's not bad. I do like that they added their source and gave credit to who put this together. So thank you, Kurt Merrill from CNN, and the data from National Oceanic and Atmospheric Administration. I think that's what NOAA stands for. But yeah, anyways, so let's look at the graph. So I do like that they have kind of points of reference here. Oh, hold on. Sneeze. Had to sneeze. Alright. Feeling better. Yeah, I like how they added some points of reference, so we kind of know, okay, Atlanta's over here. Maybe some people in the West, like in the West, Central America, you know, wherever, they might not know exactly where Atlanta is. So, you know, again, I really like the shading. It really shows which areas were hit hardest. This is what's nice about like a heat graph or a... one more time. There we go. This is what's nice about a heat graph or heat map or some sort of like some sort of density chart. It's really easy to see where everything's at, or where at least in this case, the area is most affected. Try that again. Yeah. But yeah, I like the common points of interest. Path of the hurricane. That's... Excuse me. I feel like this is definitely required to show where, obviously, where the hurricane went. I guess just a nitpick from me, I would like maybe it started here on this day and it ended here on this day, and then it like this is how far it traveled in a day, and then maybe this is how far it traveled in like the third day or whatever, and then maybe the date of landfall here, coming off, just to kind of give us a perspective of how fast the storm progressed. I think the article itself might give you a good the article itself might give you a good idea of how fast and how far the storm traveled. But yeah. What else? Oh yes. Again, like I said with the last one, I like how the Atlantic Ocean is white. Basically everywhere where there's supposed to be ocean is white. That really contrasts against that kind of focuses our eye on both the blue here and the blue, basically the blue everywhere. I think it was a really good, really important design choice. Obviously the borders are going to be really important for any kind of map. I'm trying to think of anything else that I like or don't like. I guess one other kind of nitpick. So while this is a gradient, it is kind of hard to tell between, say, this area and this area. Maybe give go here, specify the amount of inches of rain, and then here specify the average inches of rain here or there, and then obviously when you get up to this area, kind of show maybe the most affected area, and then maybe another affected area that maybe we don't know about, Um, that might just go to show, just to kind of highlight where the storm was hit most, or maybe this darker dot right here. Maybe you should point out, hey, this was up to 20 inches. 20 inches of rain from the storm. That would be really helpful. Just that's more nitpick for me. You don't need to have that in order for this to be a good graph. But it is kind of interesting, just as the user, as the end kind of consumer. That kind of information I personally really like. Yeah, that's maybe more personal preference. What else? That's about all I can think of. But yeah, again, very, very well made. Yeah, the design choices of, you know, making the ocean white, I think was really important. Just so, again, like I've already stressed before, so that way we can really, it kind of focuses our eye here in the middle. So that way we can see what's going on. Overall, honestly, I'm gonna give this an A. I think it's a great graph. It's a great example of, well, let's give it an A minus. I'd like maybe a bit better of a headline or maybe a subtitle. I guess where it's coming out of an article, that's maybe arguable, but where I'm just pulling just the graph out, that probably takes out some information. Yeah, okay. Yeah, A minus. I'll stick with that. Let's save this real quick. PNG. Alright, let's get to the next one. Okay. Let's edit and paint again. Okay. Mountains of North Carolina and Tennessee inundated. Title's good. Again, they list where the data was sourced and who made the graphic itself. So thank you again, Kurt Merrill. I guess I will say across the board for all three of these graphs, I do like that they use the same scale. Let's see. Yeah, see, this is yeah, the most hit area here. It's kind of crazy, especially like this these darker patches right here. Yeah, it's just incredible how much water. Yeah, again, I really like the points of references here, especially these hard hit areas. I would maybe add a Charleston. Where is Charleston supposed to be? I don't know the That's right. I thought Raleigh was somewhere sort of in the middle. Yeah, maybe add in... okay, so Charlotte's down here. Raleigh's up here. So Raleigh's about here, and Charlotte. Charlotte is about here. Do you add those in? Possibly. Let's look at Tennessee, see if there's any major cities close-ish by. I mean, you could add in Knoxville. Maybe add in Nashville as well to get, again, give... So, Knoxville's here-ish, maybe? Or maybe here. And then Nashville's maybe right here. Well, I guess when you look at it, when you look at this graph like a news article, what is the story? The story is this city right, these cities right here. I guess you're more trying to tell a story, or you're maybe you're not. You're trying to support the story that's being told in the article, not necessarily tell the story with 1 or 3 single visualizations. Maybe that's how we ought to look at this. Interesting. Okay. Okay. Other things that I don't like, or that I do like. I guess again, the white space of the water. I know I've already talked about that, but again, it kind of forces us to look over here and to only look over here for the graph, or for the, sorry, for the color gradient. Yeah, again, I'd really like to have maybe some sort of inch amount. Again, it's probably in the article, and so that might be a little redundant. Yeah, that's about it. A lot of the same things that I like about this graph, I've liked about the other two. I'll also give this an A. Also, kind of with a caveat that this graph does a good job of supporting the story that's being told in the article. It might not do a great job if you pull it off the screen and just look at it by itself, like what I'm doing right now. But as supporting the story that's being told and the story that's being presented in the article on CNN, this graph is doing a great job. So in that aspect, I'll give it an A. So. Let's see. All right. But yeah, check out the article. It's kind of amazing how much water, how much rain, how much water was just dumped on the people on the path of the hurricane. Just incredible. I mean, wish I could rewind that. Like, this truck is like the motorhome and this trailer. It's probably flooded with water. This car is just I don't want to say totaled, but just completely messed up. Yeah, bits of the road just that's just horrible. Flooding and mudslides damaged parts of Interstate 40 in western North Carolina. North Carolina Division of Aviation. Wow, I mean that's yeah. Oh yeah, this part of the bridge just gets swept away, along with the rest of it. I'm honestly surprised not that more of this bridge isn't being swept away. And even like look at this guy's property right here. I mean, all this water is just seeping in. You can see this huge wave just coming in. Yeah, that's incredible. On Highway 107 in Afton, Tennessee. Jeez. Dam remains intact as floodwaters begin to recede. Holy smokes. Yeah, it's just... Yeah. It looks like it's going over the top of the dam and kind of around on the side. Yeah, it looks like it's going over the top. And then this bit right here is just... It just flooded over and it's coming down here. That's incredible. Interstate Police rescue dozens of people who climbed to the roof of Tennessee Hospital to escape rising floodwaters. Holy cow, yeah. That's the roof right there, man. Oh yeah, there's the helicopter. There's another one over there. Holy cow. Oh yeah, there's another helicopter. Jeez Louise, that's incredible. Wow. It's just so sad. Yeah, wow. Oh boy. Jeez. Wow. Just incredible. I will go take a break, get a bit of water, and we'll get after some programming. I'll be right back. All right, I'm back. Uh-oh. There we go. Okay. Okay. I have an idea. Okay. Okay, so I found this post on LinkedIn. Let's see. Yeah. Okay, this was originally a post about data engineering. Actually, let me come back. Put this over here. Hold on. Okay. Alright, let me switch back over. Okay, so this is a post. Let's see. Data engineers, are your SQL queries getting bogged down? Complicated case 1 statements. Complicated case 1 statements, hard to maintain, prone to errors. If you've ever found yourself scrolling through pages, you're not alone. What if it was cleaner, more efficient way to handle these conditions? Simplifying your code, making more readable, and reducing the chances of introducing bugs while improving the performance of your queries. Okay, I'm listening. Answer lies in replacing bulky case when statements with a lookup table. By moving your logic to a dedicated table, you can streamline your SQL queries, making them easier to manage and scale. Here's how it works. Okay, let's... Wow, I cannot highlight to save my life. Here's how it works. Create a lookup table that maps your conditions to their corresponding outcomes. Let's do that again. Okay, I did the same thing again. Replace the case when logic with a simple join to this table in your query. Enjoy maintainable and flexible code base that's easy to update as your business logic evolves. For example, instead of having case 1 statements to map department ID and department name, create a department lookup table, use a left join in your query. This small change can make a big difference in your day-to-day work, keeping your SQL clean and your mind focused on more important tasks. So, the reason this is brought up, let me get it. There you are. Oh boy. Okay. So, what prompted this? How to filter in Python by both description text and by description text, date, and dollar amount. So, why is this important? Oftentimes, you will get an entry that looks something like this: 12/01, 2020. Description is Venmo for an amount of, say, $300. $300. What is that for? I have no clue. I have no idea what that $300 is for. Well, I can look it up. I can look at my Venmo at the particular date and at the particular time, but that doesn't immediately tell me. But for whatever reason, that note that I put on that Venmo transaction doesn't come over to the bank statement. At least it doesn't come over to mine. If it does come over for yours, that's phenomenal, and I hope that you use that in your data cleaning scripts. But for me, it doesn't. So I have to manually say, in order to categorize this transaction, you need to just a little bit. Oh, can I not zoom back out? That's weird. You need to, one, look up what it says in Venmo. Two, if date equals 12/01/2020 and dollar amount equal is 300. Then category equals, let's say utilities. Let's say rent. The problem with this is if you say what doesn't work is if Venmo description equals Venmo, then category equals rent. You can't do that. You need to look at the individual days and the individual amounts, and see which ones, and see what category that is, or even what company that is. It could be your rental company, it could be, you know, it could be you going out for drinks, you going out to a restaurant, you're paying somebody back. You just don't get that information with that particular line in your bank statement. You just don't get that information. So what we need to do is how to categorize expenses. How to categorize expenses in Python by description text and slash or date and dollar amounts. Sometimes if you have recurring fixed payments, so rent or internet bill, or what are some other fixed expenses people have, or like a car payment, you can use dollar amount, because if you know what the exact dollar amount is, and if you always pay on the 30th, or if you always pay on the 1st or the 15th, or you always pay on this particular day, it's going to be easy to narrow down. Plus you can add in the description text in order to narrow down what the particular transaction, right? So we need a way to do this in Python, and what we have with the dictionary currently works if we're just looking at the description. It's not going to work. It's not going to work in every case, but it'll work for your Sam's Clubs. Basically, what I'm trying to say is the solution we have isn't going to work out, and we need something more robust to be able to categorize these expenses categorize the expenses that are coming in. My thought is to make a lookup table in our SQL database that can live there, and we pull that down and we configure it, and we translate that into Python and somehow use that to clean our data. I suppose I'm not opposed to using it in to just like upload the data into SQL and then run a script in SQL to categorize expenses. that's my predicament. So actually, yeah, let's brainstorm more ideas. Let's dates. tracking. That'd be a bad idea to try to use something like that. Medium. Description, category, amount, transaction type, account balance. To pay for it, yep. Dang it. That one actually looked fairly promising. Doggone it. Oh wait, I just need to members only. Oh, come on. There. Oh, come on. Medium. Darn it. That's looking promising. Doggone it. Well, I'll keep it open. Not quite what I want. Into the database and connect a Power BI dash to rise the data that is in the database. Currently, I'm stuck on how best to clean the data. The data comes in from the bank. Are some columns I use to categorize the transaction. Oftentimes you can use the description and infer the category using the tools that I'm using Python and SQL. How would you suggest I manually categorize expenses using description and occasionally date and dollar amount. Oh, music shut off. something similar to my project. Speaking about number 3, semi-automated suggest the user update the logic when user input to up the logic, the categorization logic you've outlined in number 3. We'll learn over time base. User making it smarter. Key to store user-defined rules and dynamically apply them to future transactions. Let's see, okay. Incorporating user input and updated categorization logic in real time can be a great feature. Here's how you can approach it. Dynamic keyword addition. When a new transaction comes in that hasn't been seen before, you can prompt the user to categorize it manually and store their input for future use. This approach will allow interactive categorization. Here's a simple flow where the user is prompted to provide feedback when an uncategorized transaction is detected. User prompt for categorization, create a system. Let's see. New transaction found. Category, please categorize this transaction. You can check for uncategorized transaction and put the function above. If row category equals uncategorized, prompt the user for input. categorizes a new transaction, store that role so that future transactions are automatically categorized. You could append to predefined dictionary or use a database table to store dynamic rules. Let's see, the keywords. Based on user input, the keywords, description. This case, category, append. After user categorizes, update the keywords. Store the rules in the Postgres database. Database. User interface using web framework like Flask or Streamlit. Use can resume categorize new transactions through web interface. Streamlit. Yes, this looks like what I'm trying to do. This has been helpful. Thank you. Questions as you continue building or need help with specific features, feel free to reach out. Good luck with the project. Alright, well, thank you ChatGPT. Thanks thanks OpenAI for the yeah, thanks a lot for the help. Yeah, I'm gonna wrap there. So tomorrow, or not tomorrow, Tuesday, I'll be working to implement something like this, or yeah, some way to figure that out. But anyways, thank you so much if you've been watching. If you made it this far, I really appreciate it. Go ahead and drop me a follow, like and subscribe if you're on YouTube. Again, I really appreciate you sticking it out this far. Have a great weekend, and have a great day, morning, evening, wherever you're at, and I will talk to you guys on Tuesday.